Okay, so let's start with the Python libraries. Now these libraries are very useful and very powerful for Python, the backbone of the Python. So let's see some details about Python libraries. The first and the foremost library which is available and which is very commonly used in almost in every program is the Pandas. Now Python library is a reusable chunk of code that one may want to include in the programs or projects. Now Pandas is the short for pediatric autoimmune neuropsychiatric disorder associated. Now this was in fact developed on some say child diseases, but it was picked up from there and started started using it for the purpose of this Python language. Now this is with streptococcal infections, and that was the reason why this words were coined. So a child may be diagnosed with a Pandas. It is a kind of a disease which generally happens with the children. And when obsessive compulsive disorder, OCD, tick disorder, or both suddenly appear following a streptococcal, or also known as strep infection, such as strep throat or scarlet fever. So from there it has been picked up and used as with this the acronym that is Pandas for the Python language. This is just for our information. It has got nothing to do with the programming or anything of that sort. But this is that we must know that what exactly is Pandas. That is the only interest as a programmer that we have. So this is just for information as to where from the word Pandas came in. So Pandas is a high-level data manipulation tool developed by Wes McKinney. It is built on the NumPy package and its key data structure is called the data frame. Now data frame allows you to store and manipulate tabular data in rows of observations and columns of variables. Pandas is the most popular Python library used for data manipulation and analysis. Provides highly optimized performance. Is one of the fastest and powerful, flexible and easy to use open source data tool built on top of the Python programming language. So that is why Panda is a very useful tool available with the Python. Panda is very well suited for different kinds of data such as tabular data and heterogeneous type of columns, ordered and unordered time series data, arbitrary matrix data with row and column labels, unlabeled data, any other form of observational or statistical data sets. So any type of data can be used with the Pandas. How to install it? To install Pandas, go to command line, terminal and type pip installed Pandas. Now pip is a utility available with the Python and which is kind of inbuilt into Python itself. So you can use that to install any of the library functions. Or else if you have Anaconda, from that also we can use this Pandas. So there you can use this conda install Pandas. Once the installation is completed, go to your IDE, that is interactive data environment, which may be a Jupyter or a Python or whatever, and simply import it by typing import pandas as PD. Now this PD can be any name. It is just as, so that you can just abbreviate it and you can use it with that PD only, not writing entire Pandas. Moving ahead in Python Pandas tutorial, let's take a look at some of the operations which can be performed with the help of the Pandas. The Pandas operations, when you use Pandas, you can perform a lot of operations with series, data frames, missing data, group by, etc. Some of the common operations for data manipulations are listed below. Now slicing. Slicing is a very unique kind of operation which is possible with the Pandas. In order to perform slicing on data, you need a data frame. Don't worry, data frame is a two-dimensional data structure and a most common Pandas object. So first let's create a data frame as it is shown here. Grade is equal to, within a square bracket we have these four numbers 88, 72, 93 and 94, and suppose out of these four numbers you want to pick up 2 or 3 or whatever number. So you can simply by writing this you can slice it. That is what is known as slicing. You can slice that particular numbers. Refer the below code for its implementation in PyCharm. So import pandas as PD, then XYZ web, then day 1 2 3 4 5 6 whatever. This is the name of the column. Day, visitor is again a column, and these are the, of course, the elements within that particular column. Then bounce rate is another column, and then within that again you have the elements, and like that. So you can define all that with df is equal to PD. PD is pandas, and data frame XYZ web. XYZ that I've already defined in the first line. And then when you print the df, you can see the output coming in like this, as you can see on your screen. This 0 1 2 3 4 5 6 is the index. So this is an inbuilt into the Python itself. So you can see that bounce rate, day, visitors, all these, whatever you have given at in that particular string, you can see all that. You can rearrange also. The columns can be rearranged. So in Jupyter, if you see, the output will be something like this. So like that, it becomes easier for you to manipulate the data. There is another library function known as NumPy. Now NumPy is an open source numerical Python library. NumPy contains a multi-dimensional array and matrix data structure. NumPy is a Python library used for working with arrays. It also has functions for working in domain of linear algebra, Fourier transform, and matrices. NumPy was created in 2005 by Travis Oliphant. It's an open source project and can use it freely. NumPy stands for Numerical Python. In Python, we have lists that serve the purpose of arrays, but they are slow to process. So NumPy aims to provide an array object that is up to 50 times faster than the traditional Python list. So that is why NumPy becomes very, very popular, very useful. The array object in NumPy is called ND array. It provides a lot of supporting functions that make working with the ND array very easy. Arrays are very, very frequently used in data science, where speed and resources are very important. Now NumPy is a library consisting of multi-dimensional array, objects, and collection of routines for processing the arrays. Using NumPy, mathematical and logical operations on arrays can be performed. It is the core library for the scientific computing, which contains a powerful n-dimensional array object, provides tools for integrating C, C++, etc. It is also useful in linear algebra, random number capability, and NumPy array can also be used as an efficient multi-dimensional container or generic data. Now how to install NumPy? To install NumPy again is very simple. Go to command prompt and type pip install NumPy, like we have done in case of Pandas. Now once the installation is completed, go to your IDE and then simply import it by typing import NumPy as np. Let's understand what exactly is a multi-dimensional NumPy array. In the picture below, we can see so many numbers mentioned in the squares of the matrix. This is how the shape you will see. You can imagine at least. These are known as elements. You can see in the first row that A00, A01, A02. This is how the elements can be defined in a matrix, which is an array. Then A10, A11, A12, like that you can keep on defining, and this is how we can imagine that how the numbers are going to be stored. The different elements are stored in their respective memory locations. It is said to be two-dimensional because it has rows and columns. In the above image, we have 3 columns and 4 rows available. We can check interactive data environment like PyCharm or Jupyter, etc., and see that how we can present it on our screen if you want to see it there. Now single dimensional NumPy array, import NumPy as np, and then you can write this function like a is equal to np array 1 2 3, and when you print it, you will see the output as 1 2 3. Then similarly multi-dimensional array, again you can define like this as it is shown here. A is equal to NP array, then within small brackets, then again square brackets, again small brackets, 1 2 3 and 4 5 6, and then when you give a print command, that is print A, you can see that the output will be like this: 2 rows, 1 2 3, and then second is 4 5 6, and then they are all enclosed in the square bracket, and then the 2 square brackets are there. So this completes the first part of our Python library tutorial, which is very useful, right? Thank you.